said.
I remember I blogged the whole thing. www.creedthoughts.gov.www/creedthoughts. Check it out.
Last year, Creed asked me how to set up a blog. Wanting to protect the world from being exposed to Creed's brain, I opened up a Word document on his computer and put an address at the top. I've read some of it. Even for the intranet, it's pretty shocking.
I'm here with my brother and my father, sort of a family reunion. This is Howard Joel. This is from my father.
Wrote this short essay on her website, basically, that says 70 years of AI has taught him and taught, other people in the AI community from his perspective that when AI researchers leverage domain knowledge to solve problems, like, chess or something, we build complicated methods that essentially don't scale, and we get stuck, and we get beat by methods that leverage scale a lot better. What seems to have to work better, according to Sutton, is general methods to scale, and he identifies search, which is not like retrieval, more of like exploring large spaces, and learning, so getting the system to kind of understand its environment, maybe, for example, work best. And search here is what we'd call in the LLM land maybe inference time scaling or something. So I don't speak for Sutton, and I'm not, suggesting that I have the right understanding of what he's saying or that I necessarily agree or disagree, but I think this is just fundamental and important kind of concept in this space. So I think it raises interesting questions for us as people who build, and engineer AI systems. Because if leveraging domain knowledge is bad, what exactly is AI engineering supposed to be about? I mean, engineering is understanding the domain and working in it with a lot of human ingenuity in repeatable ways, let's say, or with principles. So, are we just wasting our time? Why are we at an AI engineering, fair? And I'll tell you how to resolve this. I've not really seen a lot of people discuss that. Sutton is talking about, and a lot of people throw the bit of lesson out. Clearly, somebody has to do that, right? Sutton is talking about maximizing intelligence. All of us probably care about that to some degree, but which is like something like the ability to figure things out in a new environment really fast, let's say. All of us kind of care about this to some degree. I'm also an AI researcher. But when we're building AI systems, I think it's important to remember that the reason we build software is not that we lack AGI. We build software, and the reason for this, and the way to kind of understand this, is we already have general intelligence everywhere. We have 8 billion of them. They're unreliable because that's what intelligence is, and they've not solved the problems that we want to solve with software. That's why we're building software. So we program software not because we lack AGI, but because we want reliable, robust, controllable, scalable systems. And we want these things to be things that we can reason about, understand at scale. And actually, if you think about engineering and reliable systems, if you think about checks and balances, in any case where you try to systematize stuff, it's about subtracting agency, subtracting intelligence in exactly the right places, carefully, and not restricting the intelligence otherwise. So this is a very different axis from the kinds of lessons that you would draw on from the bitter lesson. Now, that does not mean the bitter lesson is irrelevant. Let me tell you the precise way in which it's relevant. So the first takeaway here is that scaling search and learning works best for intelligence. This is the right thing to do if you're an AI researcher interested in building, agents that learn really well, really fast in new environments, right? Don't hard code stuff at all, or unless you really have to. But in building AI systems, it's helpful to think about, well, sure, search and learning, but searching for what? Right? Like, what is your AI system even supposed to be doing? What is the fundamental problem that you're solving? It's not intelligence, it's something else. And what are you learning for, right? Like, what is the system learning in order to do well? And that is what you need to be engineering, not the specifics of search and not the specifics of learning, as I'll talk about in the rest of this talk.
This framework is not meant to be a new, efficient way to do computer vision in production. Instead, it's a standardized test, a benchmark, that for the first time lets us put a model like GPT-4o on the same playing field as a specialized vision model and get an apples-to-apples score. Here's how it works in practice. Let's take object detection.